Google's quantum chip, unlocking mysteries or shattering physics. In a groundbreaking development that has sent shockwaves through the scientific community, Google's cutting-edge quantum computer chip, hailed as a state-of-the-art marvel, has just recorded results that seem to defy the very foundations of quantum mechanics. These anomalies are so baffling that experts around the world are scrambling to interpret the data. The implications of these findings could upend decades of established scientific theory, potentially unraveling the secrets of the universe or exposing flaws in our understanding of reality itself. Is Google's quantum chip revealing the hidden truths of existence, or could it be something far more unsettling, a harbinger of unknown forces at play in the quantum realm? While the idea of quantum computers might sound like something straight out of a science fiction novel, they are very much a reality today. At the forefront of modern physics and computing, quantum chips represent the pinnacle of technological innovation. Traditional computers store information in bits, which are either a 0 or a 1. In stark contrast, quantum chips utilize quantum bits, or qubits, which can exist as 0, 1, or both at the same time, a phenomenon known as superposition. This ability to exist in multiple states simultaneously allows quantum computers to perform complex calculations at speeds that were once considered unimaginable. Over the past few decades, scientists, engineers, and tech giants such as Google, IBM, and others have been pouring massive resources into the development of quantum computing, claiming major breakthroughs in the quest for quantum supremacy. However, as researchers push the boundaries of what these extraordinary devices can accomplish, they are beginning to notice strange and unexpected phenomena, oddities that defy explanation. In laboratories around the world, researchers are reporting bizarre fluctuations, unexplainable results, and even outcomes that don't align with the established rules of quantum mechanics. One of the most perplexing aspects of these observations is the suggestion that quantum processors might be interacting with something beyond the known laws of physics. In some experiments, qubits appear to be producing results before the calculations officially begin, as if they are tapping into a realm where cause and effect no longer follow the expected timeline. Could these quantum processors be reaching into the future, or could they be bending time itself? While such a claim might sound like the stuff of science fiction, the raw data is suggesting something genuinely unusual. Some researchers have even speculated, albeit half-jokingly, that these anomalies could be the result of quantum systems interacting with parallel universes or hidden dimensions. This idea is rooted in the concept of multiverse theory, a theory that, in quantum mechanics, multiple possible outcomes can coexist in separate realities. While mainstream scientists remain cautious about the implications of this theory, rumors are circulating that some quantum chips might be tapping into these unseen realms, with data flowing between different dimensions. The crux of the matter is that quantum experiments are notoriously sensitive to interference, such as temperature fluctuations and environmental noise. But in the case of Google's quantum chip, often referred to by the code name Sycamore, the strange results don't appear random, they follow a discernible structure. This structured anomaly suggests that something deeper is at play, challenging even the most established minds in physics. Google's quantum chip, which operates in highly controlled environments, typically cools down to temperatures close to absolute zero, just a fraction of a degree above the coldest possible temperature known to science. This extreme cooling reduces thermal noise and helps preserve the fragile. However, during routine experiments, something unexpected occurred. For certain operations, the chip produced results moments before the classical instructions were even sent. At first, the researchers assumed it was a simple calibration error. But after repeated tests with advanced error correction protocols, the same baffling pattern kept emerging. Even stranger, some qubits weren't collapsing into a definitive state when they should have. Normally, when a qubit is measured, it behaves like a coin that lands as either heads or tails, choosing one state from the superposition. But some qubits in Google's system refused to settle on a final state for longer than expected, defying the strict timelines that quantum systems are known to respect. This wasn't just a simple glitch, this anomaly had a pattern, and that's what's so perplexing. Identical simulations produced inconsistent results, something that's unheard of in classical computing. Physicists have long accepted that when you run the same experiment with the same inputs, the results should, in theory, be the same. Yet the repeated variations in Google's experiments seems to follow an unexplainable pattern, something outside the standard laws of quantum mechanics. After carefully analyzing the data, researchers concluded that it wasn't random or caused by typical errors, but something far more elusive was manipulating the outcomes. Could this be a brand new quantum effect, an undiscovered phenomenon? Or could it be that quantum computing is far more complex than we ever imagined, potentially involving new forms of entanglement or superposition? If proven true, these findings could lead to breakthroughs in fields like cryptography, quantum simulation, and perhaps even the ability to manipulate quantum fields directly. But, of course, there's the possibility that it's simply a flaw in the design, but even that would be a major revelation. After all, no one in the field has seen anything that systematically suggests a violation of physics like this before. As if things weren't mysterious enough, some researchers are now entertaining the highly speculative idea that quantum processors could be interacting with parallel universes. The concept comes from the many worlds interpretation of quantum mechanics, which suggests that each possible outcome of a quantum event creates a new universe. In this context, it might be plausible, though highly speculative, that quantum chips could somehow access information from these parallel universes, explaining why some calculations seem to happen before they should, or why some results arrive faster than expected. If this theory holds water, it would suggest that our current understanding of time itself, one of the bedrocks of physics, might need a major overhaul. For instance, in the case of Google's chip, the device might not be confined to our linear perception of time. It could be reaching across these parallel timelines to gather data or even influence its own calculations in ways we can't yet comprehend. This radical theory is controversial, to say the least. Most scientists view the many worlds interpretation as a metaphor, or a mathematical tool rather than a literal description of reality. But the fact that these anomalies keep cropping up in experiments that are under tight scrutiny has given the theory some traction in certain circles. If this hypothesis is correct, it would open the door to a host of implications, such as the ability for quantum systems to access hidden dimensions or manipulate timelines, pushing the boundaries of what we think is possible. But of course, skeptics are quick to argue that the observed anomalies could be explained by issues with the measurement process. Perhaps the system is out of sync by a fraction of a second, or maybe environmental factors like cosmic rays are interfering with the hardware. These explanations could account for the strange results, but none